Okay, today I'm gonna share some experience with a new optimization algorithms called particle swarm optimization. It's also called PSO. This PSO algorithm is inspired from the nature, like the birds and the fishes. And like scientists found that a swarm of the birds, they can always find the best path to the food, and always the path is the shortest path. So scientists from their activities to create this kind of the algorithms. So if you guys have interest about this topic, you can find this book called Swarm Intelligence from Nature to the Artificial Systems. It's a very good book. So I will show you some the important features of the PSOs. First, the PSO is a kind of the evolution algorithms. So like the GA and DE, it's evolution based, but it has its own features. For example, the second point, all the particles in the algorithm do not die or be removed. So this is totally different from the GA and DE. For GA, for example, GA, if one chromosome, its fitness is bad, so it will be eliminated in the next generations. Only the best fitness chromosome can be kept in the next generation. But for the PSO, and all the particles in the swarm, they will not die. They only change the position and velocities. And the third is, we'll suppose that all the particles that have some kind of memory, they can memorize their position and speed. We'll call them the personal based position, like it shows, and global based position so far. So for each generation, for example, we went to on the fifth generation, the particle can memorize the base position so far. So this is one suppose. And what's the application? From the above features, so the PSO always used as dynamic optimizations, and also the path planning, and in the mechanics they also used as multi-robot coordinate. Like this picture shows, for example, if we can say the real point is a robot, so how to coordinate this robot to the destiny. So this is also can be done by the particle swarm of optimization. And so today's optimization example is a very famous benchmark function called Griewangk. So I will first show you its picture. So on the picture, so from first side you can see it's like a board, but after I zoom in, you can see there's a little bumpy. So it's not a surface. So it's bumped on the surface. So it's like the first benchmark function. It has a lot of local optimals. Like this point is these are all the local optimals. So we will show say the PSO if he can find the base global point. So this is the main function of the PSO. It's about 89. So these are some important parameters. So it's learning factor, global factors. So you need to change all them. So you need to change the important parameter is the n and m. N is the number of dimensions, also the number of variables. If you have 3 variables, 4 variables, you change this number. Also, you have to change the boundaries. If the boundary is the same, you can use this one. And this one also set as if you want to test your algorithm, you want to run them 30 times, you can use these parameters. So I will run this program. Okay. Okay, you can say I said this, the iteration is 200. So actually, when the algorithm goes to the 150 or 150 times, it got the global optimal. And we also put that the global point at this into this 3D, three-dimensional pictures. So we can say the global optimal is here. It's right at the global point. So this is the example, and I also upload all the files to the MATLAB, so you can directly download them. Okay, thank you.